Hello, everyone. My name is Kelly Hall. I'm a marketing coordinator for ALS North America. I want to thank you all for joining us today for our Webinar Wednesday series. Our presenter today is Clif McLellan. Clif received his Bachelor of Science in Biology and Chemistry from Eastern Michigan University in 1994 and his Master of Science in Toxicology from the University of Michigan in 1997. With more than 24 years of experience working with Standard 61, Clif has helped companies, governments, and industries improve the safety of water and water-related products. Clif served as the Director of Toxicology for many years and was the Vice President of Global Water Programs for NSF International until he joined ALS in 2018. Now he serves as the Director of Product Certification for our ALS laboratory in Irvine, California. Today, Clif will be discussing why products fail Standard 61 certification. During this presentation, feel free to use your chat box, ask a question, or raise your hand features to ask your questions. All questions will be answered at the end of his presentation. Clif, thank you for taking your time today. I will go ahead and turn it over to you.
All right, thank you very much, Kelly. The good news about product failures to Standard 61 is that most of the chemicals that fail Standard 61 testing are chemicals of low toxicology concern. The bad news is that if a product fails, it can keep good products from the marketplace and result in repeated expensive testing without providing a public health benefit. This statement is not intended to dismiss the toxicology concerns with substances like lead, nitrosamines, or similar toxic compounds, but it's intended to emphasize the case that most material extraction failures are due to compounds which have artificially low pass-fail levels and low confidence regarding the identity because the chemicals have not been studied and not because they've been determined to be a health risk. Today in my presentation, I'd like to identify common causes of failures and provide to manufacturers some guidance on what they can do about them. As an introduction to ALS Limited, we are a multinational corporation headquartered in Houston, Texas, and we are a leading provider of testing, inspection, certification, and verification services globally. Our total staff count is over 13,000 people at 370 locations across 65 countries. In 2018, ALS Limited acquired Truesdail Laboratory, which now goes by the name of ALS-Truesdail. Our office and laboratory are located in Irvine, California. The ALS Laboratory has been providing quality testing since 1931. We are a fully accredited independent laboratory and certification body, and our certifications include certification to a number of ANSI NSF standards, WaterSense certification, ASTM, ASSE, and CSA standards. ALS-Truesdail is a fully accredited certified drinking water products for use in every state in the U.S. and all of the Canadian provinces. Our accreditations include meeting all of ANSI and Standard Council of Canada requirements, as well as meeting a number of ISO standards, including ISO 17065 and 17025. This slide showcases a number of the companies that we certified to Standard 61, which among many others include Mueller Industries, Ford Meterbox, Zurn, Clayval, Nibco, Red and White Valve, and E-Pipe. I would like to present each of the major material types and talk about the occurrence rate and common causes of failures, starting with the vinyl materials, which include rigid PVC and CPVC. The key thing to know about rigid vinyl material is that they rarely fail. There are times when the tin stabilizer may leach at high levels for a single day test, but these failures are easily resolved by performing multiple day testing. Extraction issues related to the vinyl chloride monomer, which would be of toxicology concern if it existed, have been resolved many years ago. Manufacturers recognized the potential for this to be a problem, and they applied various technologies to eliminate the leaching of residual vinyl chloride monomer. VOC testing for vinyl material is a mandatory test. Other than a series of VOCs that are commonly detected at very low levels, failures are rarely seen. The testing for VOC was originally instituted because there was a lack of knowledge around the potential for VOC extraction from rigid vinyl material. If you were to review the compounds that are tested in the VOC test method, it becomes apparent that there's no source of these compounds found in the formulations. And if you appreciate the high heat that is used to make rigid vinyl pipe, you can easily come to the conclusion that testing for VOC compounds may not be necessary. Failures for copper pipe is also very uncommon. Copper is made of 99.9% copper, so there's little chance that the copper pipe or fitting could fail for anything other than copper. There have been problems with copper extraction in the past when products were tested using pH 6.5 test water because the water was unstable and the pH drifted downward during the test. This change in the pH during the test resulted in a corrosive water condition that would cause copper to be etched from the pipe surface. This problem was recognized, and now a corrosive resistant water is used to test the copper pipe and fittings, and the same failures no longer occur. Copper pipe also has a history of failing due to lubricants that are used during the manufacture of the pipe. The original reason these products failed was because the compounds had not been seen before, and their pass-fail levels were set at the threshold of evaluation of 3 parts per billion, which is artificially low. Once the risk assessments were performed on these food-grade lubricants, the established pass-fail levels far exceed the level of extraction of these food-grade lubricants, and failures no longer occurred. While a failure for a material extraction test is always possible, the likelihood of having a repeatable test failure for this material is very unlikely. Historically, the failure mode for brass and bronze materials has been related to the leaching of lead. Exposure to lead has been well studied, and the negative effects due to lead are well known. We can do many webinars on the leaching of lead from brass and bronze or the negative health effects due to lead. The good news is that manufacturers continue to decrease the use of lead materials as well as finding substitutes for leaded brass and bronze. However, there's still a significant amount of progress to be made in replacing old infrastructures and continuing to find ways to reduce lead exposure to humans, particularly to children. There are a few things manufacturers can do to lower lead extraction from lead alloys. The first is that the one I had already mentioned, and that is to reduce lead content in metal alloys. The lower the percent lead content in the material and the lower surface area of the lead-containing material in contact with water results in lower amounts of lead in drinking water. Another thing manufacturers can do is to maintain a consistent supply chain. This means that manufacturers must maintain a quality supply chain which assures they are receiving the same low lead material that has been specified from their supplier. Thirdly, lead exposure can be reduced during the manufacture of alloys by keeping the processing temperatures low during the machining process and to change the casting sand on a regular basis to minimize lead contamination of their product. For nickel-plated products, failures related to the lack of coating permanence is the main cause of failures. There are tests that can be done by manufacturers to assure a coating will be permanent and the nickel coating does not come off. These tests should be performed by the manufacturer. Failures associated with flexible PVC are almost exclusively related to the plasticizers that are used to make the material soft. Plasticizers leach because they do not become part of the polymer matrix of the material. The solution for the manufacturer is to select plasticizers that have had risk assessments performed and have low toxicity profile. Plasticizers like diethylhexyl phthalate or DEHP have low pass-fail criteria, and they frequently result in failures. Using substances like DEHP as plasticizers should be avoided. In this slide, I've grouped a number of materials together that have a series of common problems because they all have formulations with the same components. All these materials consist of polymers, initiators, terminators, curing agents, antioxidants, and process aids. In addition, they can also contain pigments, antimicrobials, and plasticizers. Not all of these substances become part of the polymer matrix, and the ingredients themselves can contain impurities, degradation products, and hydrolysis products, which can cause failures. In addition, many of the compounds that do extract do not have toxicology data to support a risk assessment. The result is that many of the compounds reported in these material extraction results are compared to an artificially low default pass-fail criteria. There are a few things a manufacturer can do to prevent these failures. The manufacturer would benefit by comparing the purity of their starting ingredients and selecting those with the highest consistent purity, because many of the failures are due to impurities, degradation, and hydrolysis products in these ingredients. Purchase ingredients with high purity can reduce frequency of failures. Another thing a manufacturer can do is to maximize the use of each ingredient in the formulation by using only the amount that's necessary to meet physical specification and performance requirements of the material, while balancing the manufacture time and the chemical use. Manufacturers can also consider the use of post-curing their materials. Post-curing that includes heat can reduce the presence of volatile and semi-volatiles. For coatings, there are a couple of additional factors to consider. Improper mixing and application of the coating test slides can be associated with failures, in addition to clients applying for exaggerated use conditions. The potential issues associated with improper mixing are self-explanatory, but the subject of clients applying for exaggerated use conditions may not be. Sometimes a client will apply for a smaller tank or pipe size than a coating will be used for due to perceived or real marketing advantages. Test results are evaluated based on surface area to volume ratio, and the smaller tanks have a larger surface area volume ratio. The final test results come out higher for the smaller tanks, and a product would fail when it otherwise would pass if it was evaluated to the proper size tank or pipe. This slide provides information which shows failure frequency of various products. This was published by NSF on their website. You can see that the faucets and coatings are reported to have the highest frequency of failure at 13, and the remainder of products average between 5 and 6%. Next, I would like to talk about the impact that the various test methods have on the outcome of testing. The methods listed on this slide are the most tested method used for products evaluated as standard 61. They include various specific test methods for single compounds, EPA method 200.8, which is used for metals, EPA method 524, which is used for VOCs, and EPA method 525 and 625 for semi-volatiles. Semi-volatiles, as the word suggests, are organic compounds that are volatile but not as volatile as some of the compounds you would consider as volatile, like toluene, xylene, benzene, and others. You can see on this slide that there are a certain amount of air that's associated with the various testing. Compound-specific methods where standards are used, and EPA methods 200.8 have a low amount of air and provide accurate results to within plus or minus 3%. EPA method 524 also provides very accurate results. The higher percent air occurs at the lower concentrations, and accuracy improves at higher concentration. And this level of accuracy of plus and minus 3 to 10% is the same for EPA method 525 and 625 when there is an authentic standard used. The error in measurement greatly increases to plus and minus 100% or more for GCMS methods 525 and 625 when our authentic standards are not used. The vast majority of product failures are due to compounds identified using these methods, which do not have an authentic standard for comparison. This group of compounds are referred to as tentatively identified compounds, and most of these compounds are evaluated using artificially low pass-fail criteria of 3 and 0.3 parts per billion due to the lack of information. The unfortunate irony is that the compounds that have the greatest error associated with their measurement are the same compounds that have the least amount of data to assess their safety. This table shows the number and percentage of compounds that are reported in the pass-fail table in Standard 600 for compounds that are tested with reference materials and those that are tested without reference materials. Most manufacturers could not be expected to predict what may be identified prior to having their product tested for the compounds that are tested without reference material. While this collection of data is not a direct reflection of the failure rate due to the compounds that are tested without a reference material, our experience is that the failure rate for this group of compounds is actually higher than 83%. And allows for an exemption of evaluation due to the lack of certainty regarding the identification of the compound and the inaccuracies of the analysis. I'd like to thank you for your attention, and I would be happy to take a few questions.
Thank you, Cliff. Yes, we will go ahead and open it up for questions. Remember, you can use your chat box, the ask a question, or the raise your hand feature if you want to ask a question directly to Cliff. Well, we'll go ahead and give everyone a few moments. As participants are thinking of any questions they may have, I do want to inform you of some updates. This webinar presentation has been recorded. All the participants on this webinar will receive a follow-up email once the recording is available to view. We also post our webinars on our ALS Global website and our YouTube channel. There you will find a wide range of video resources and also some past Webinar Wednesday presentations. I don't see any additional questions coming in. So with that, I just want to thank everyone today for attending our Webinar Wednesday series, and enjoy the rest of your week. Thank you, Cliff.